A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss some questions related to three-dimensional geometry plane. So class, in previous lecture also I have discussed the questions related to three-dimensional geometry. Now come to the question. Now question is, find the distance of this line. Question is, find the distance of the plane. Find distance of the plane 2x minus 3y plus 4z. 2x minus 3y plus 4z minus 6 is equal to 0 from the origin. From the origins. Now this is our question. We have to find the distance of the plane from the origin. So see, this is the given equation of plane, and now which have to convert in the form of Lx plus my plus nz is equal to d, and where d is the distance of the plane from origin. So how we can calculate? Suppose we have a question and you have to find out their directions, cosines. So the direction ratios of the normals to the plane are, this is given, 2, minus 3 and 4. Now see, solution. Now the given equation of plane, that is 2x minus 3y plus 4z minus 6 is equal to 0, and this one we have to convert in the form of Lx plus my plus nz is equal to d form. So since the direction ratios of the normal to the plane are, from this question, from equation 1, suppose this is 1, the direction cosines or the direction ratio of the normal to the plane, the direction ratios of the normal to the plane that is what we can write, that is 2, minus 3 and 4. This is the direction ratios. Now what will be the direction cosines? Therefore direction cosines, that is equal to 2 upon root over 2 square plus 3 square plus 4 square. So result will be 16 plus 9 plus 4, that is 16 plus 9 plus 4, that will be 29, comma minus 3 upon root over 29 and 4 upon root over 29. So this is the direction cosines. Now divide by, or equation, what we can write? We have to divide by root over 29 in this equation. So therefore 2x minus 3y plus 4z minus 6 is equal to 0. We are going to divide by root over 29 upon root over 29. Now this format you will see, this is 2 upon root over 29 x minus 3 upon root over 29. This is y, and 4 upon 29 z is equal to 6 upon root over 29. So this is the format. And now this is Lx and this is My and this is Nz is equal to D form. Now distance of the line from origin, distance of this plane from origin, what we can write? Now D is equal to 6 upon root over 29. This is the answer. Units. This is the answer. Now I will come to the next question. The next question is question number 2. See, now question number 2 is, question number 2 is, find the coordinates of the foot of perpendicular. Find the coordinates of the foot of perpendicular drawn from origin to the plane. Coordinates of the foot of perpendicular drawn from the origin to the planes and plane is 2x minus 3y plus 4z minus 6 is equal to 0. 2x minus 3y plus 4z minus 6 is equal to 0. Minus 6 is equal to 0. So this is the given equation of plane, and we have to find the coordinates of the foot of perpendicular. So first of all, we have to write this equation of plane in terms of normal form. Now see, the given equation of plane this is and equation of plane in normal form. What we can write? Equation of plane in normal form. So 2x minus 3y plus 4z is equal to 6 and divide by root over 29, you know, root over 29. Because 16 plus 9, 25, 4, 29. So this is the format of Lx plus My plus Nz is equal to 0. Lx plus My plus Nz is equal to 0 for now here you will see direction cosines are, here you will see means direction cosines of line, direction cosines of OP, suppose this is the plane and this is the direction cosines of the line perpendicular drawn from plane of the line, cosines of the line OP. Suppose we have drawn this type of plane, you will see any plane whose perpendicular distance from the origin, whose perpendicular distance from the origin this is the perpendicular, this is the OP, X, Z and Y axis. This is OP and you know direction cosine, this is the direction cosines of the line and we have to find the coordinates of the point or coordinates of the foot of perpendicular drawn from origin to this line. So what will be the points? You can see, suppose any points, you can take this is the point P coordinates, we have to find P coordinates. So P coordinates we have considered, suppose x1, y1 and z1. So point P lies in this plane and this point will satisfy the equation of plane. So how we can solve it? This point satisfied the equation of plane. So how we can write this? See, this one we can write x1 upon 2 upon root over 29 and similarly plus, or we can write equal to y1 upon direction cosines, that is minus 3 upon root over 29 is equal to z upon, or z1 we can write, z1 we can write 4 upon root over 29. So this is the numerical value and we can consider that is k, because this is the line that passing through origin. So and this point x1 y1, so you know this is the equation of line, we can write this and when you will calculate x1 y1 z1, so you will get this result x1 y1 z1 is equal to k2k upon root over 29. x1 y1 z1 means x1 y1 z1, what we can write, this is 2k upon root over 29 comma minus 3k upon root over 29 and next 4k upon root over 29, and k value, when you will see value of k, what we can write, k value is, putting this equation, this point we have to put in equation 1 and you can get this value. So value get k is equal to 6 upon root over 29, where k is equal to 6 upon root over 29. Upon root over 29. Now this is the question. See, now I will come to the next question. The next question is, come to the next question. The next question is, find the length of the perpendicular from origin to the plane is given vector r dot 3i minus 4j minus 12k plus 39 is equal to 0. Also write the unit vector. Normal to this plane. We have to write the unit vector normal to this plane. Normal to this plane. Now see the solution. What will be the solution? Given equation of plane, that is r dot 3i minus 4j vector minus 12k and plus 39 is equal to 0. This is the given equation of plane. Now in terms of r dot n is equal to d, when you will convert or when you will equate vector r dot vector n cap is equal to d format, you will see n is equal to vector n is equal to minus 3i plus 4j plus 12k. This is the n vector. Now in this question we have to find the length of perpendicular drawn from origin to the plane. Distance we have to calculate. So what will be the distance? This is the vector n and we have to find the normal vector. So in case of normal vector, we have to divide by the terms of mod of n. So this implies mod of n vector. What we can write? 9 plus 16 plus 144, 25, 169, 160, 144 plus this is 25, 169. 169 means 13. So this result is 13. Mod of n vector is 13 result. Now r dot vector r dot vector n cap is equal to d form. So we have to convert in unit vector format. So what will be the result when you will convert this one in unit vector form? So vector r minus 3i plus 4j plus 12k is equal to 39 and whole upon 13 whole upon 13. Now this is the form of unit vector. This is the form of unit vector n cap. So distance is 3 and this is 3. This is the result D. Now distance of the plane from origin, that is D. So distance of plane from origin, that is 3. Now we have to calculate the unit vector normal to this plane. Unit vector normal to this plane, what we can write? Unit vector normal to plane, that is this result minus 3i vector plus 4j vector plus 12k vector whole upon 13. So this is the unit vector normal to the plane, and we can write also minus 3 by 13i plus 4 by 13j plus 12 by 13k. Now this is the answer. Answer is 3 also. So D is equal to 3 and this is the answer. This is the unit vector. Now see. If any doubts, can clear it. So in this question we have to find the equation of or length of perpendicular drawn from origin to the plane, and the given equation of plane is vector r dot 3i minus 4j minus 12k plus 39 is equal to 0. Also we have to write the unit vector normal to the plane. So given equation of plane, we can write vector r is equal to vector r dot 3i minus 4j minus 12k plus 39. So vector r dot and vector n is equal to unit vector n is equal to d. You know this formula we have written. This is the formula. Now this one we can write, or vector n from this expression, you know, this is minus 3i plus 4j plus 12k, and mod of vector n means mod of vector n, what we can write? Mod of vector n we can write 13, and vector r dot unit vector n is equal to d form. So we have to divide by 13 because vector n or unit vector n result is vector n upon mod of vector n. So this is the form, and we have solved this. So when we will calculate and compare from the general term equation of plane whose perpendicular distance from the origin r dot n is equal to d. So comparing, you will get 3 distance, that is 3. This is 3. So distance will be 3. Now unit vector perpendicular or normal to this plane result, you will see, that is minus 3i plus 4j plus 12k whole upon 13, and separately in scalar components or vector components, we can write minus 3 by 13i plus 4 by 13j plus 12 by 13k. So this is the answer. Now you can see. If any doubts, can clear it. So there are so many questions related to these topics. You can do yourself, and from given equation of plane you can find distance, and through the distance and position vector and given points you can calculate the equation of plane also. So various type of questions in your book, and you can do yourself this type of questions very well. So see, this topic is totally completed. R dot n is equal to d format, equation of plane whose perpendicular distance from the origin is totally completed. And I have given so many questions in class. This will do in your homework.